Welcome to lecture 35, and we have been discussing about three phase transformers, and three single phase transformers I have taken earlier, each of rating this much, and I showed you a simple star star connection. Okay. The terminals markings are essential along with polarity marking. So, I have assumed because three transformers are there, I will name them A transformer, B transformer, C transformer. Capital A 1, A 2, small a 1, A 2 are respectively high voltage and LV side terminals, and I have presumed that this 1 are the dots for all the phases. So, that is there. So, here also it was dot. Okay. Anyway, so and then I told you how to make a successful star connection, and the rating of each transformers were 5 kVA, and maximum kVA this three phase transformer, which has been formed by using three single phase transformer, each of rating this, will become 15 kVA, and it is pretty fine. I mean, each one is 5 kVA, you can handle 15 kVA, that is good. Now, today I will go slightly, we will try to tell you this one very important thing, why polarity is so much important. For example, when you take three, because we will start delta connection. So, it is better to appreciate this point. What do I mean by star connection? If suppose three resistances are there, I ask you to connect them in star, means any one terminals from each of these elements you short them, either you short it, it is a star connection, or you could short it like this also, this and this will be also star connection, no difference. So, star connection means two terminal devices, three are there. So, one from each you just short them without asking any polarity or this that is what I am telling. Similarly, what is delta connection? So, this is also star, this is also star. Suppose they are resistance or inductance or capacitance, any way you connect it is fine. Now, suppose I ask you to connect this thing in delta, three resistances. What is this connection? This connection in language we tell it that connect them in series first, this series and close this path, it becomes delta connection, and from the junctions you take the output. Although we draw it like this, that is fine. Here also we are doing this second resistance, third resistance you connect, and from the junctions you take the output, and it gets delta connected. Is this different from this? No. So, this is the way we will be drawing delta connected here. Coils will be in series and closed, and from the junctions you take the outputs, that is it. Acha, if that be the case, then suppose I say that somebody has a three single phase transformers like this, A 1, A 2, B 1, B 2, sorry, A 1, A 2, each secondary, small a 1, A 2, and then I will name them letters, 3 are there. So, B 1, B 2, small b a 1 b 2 and this is small c 1 c 2, identical transformer c 1 c 2. Suppose he does not care, a careless person for example, he argues that okay, star connections I know one from each I will short and other 3 p terminals will become the terminals of the star connected devices. So, he does like this. For example, he does not care about polarity. He tells that okay, this is also my star connection, why not? And he tells that you connect this, although I know for discussion purposes, but I know that capital A 1 small a 1 are dots, capital B 1 small b 1 dot, capital C 1 small c 1 not dot. This is the actual thing which is prevailing, but he does not care. What he does? He tells that this is the thing, connect the star in the primary going by this general definition of star and decides that he will give supply to, supply has got 3 terminals A s, B s, C s of phase sequence A B C. He gives supply to here A, then this B supply terminal, what he does? He gives it to here, are you getting me? B and C supply he gives it to there, and he tells that I have connected the primary in star and I have energy. Secondary he has not done anything. Now, in this case if you look carefully, the supply is balanced 3 phase. Okay? Supply is a balanced 3 phase system and you have connected like this. So, so supply A 1 is connected to A s and B s, B 2 terminal has been connected to B s. So, with respect to neutral it will be just not correct in terms of phase sequence, because what we know that A s, B s, C s is a balanced 3 phase system. For example, A s, this is suppose supply neutral, this is your B s, this is C s. Now, you have energized the primary of this coil with a voltage, this voltage, and this A s is A 1, is not, and your this N s is equivalent to your A 2 1 by root 3 times. B s I have connected to B 2, is not, I have connected to B 2. Therefore, this B s terminal is B 2 and B 1 is connected here. So, B s is B 2 I have connected and here is your B 1. Similarly, C s I have connected to C 1 and this is C 2, that is fine. This is what I have done. Now, on the secondary coils there will be induced voltages following the rules of single phase transformer. Capital A 1 A 2 you will get a voltage here, because these polarities are correct polarities are like this. So, you will have a voltage here A 1 A 2. For the second transformer you will have B s is connected to B 2, you will have a voltage phasor parallel to this B 2 B 1, that is what you will get, and here C s is C 1 C 2 you will get. Okay. Now, the point I want to make it, without doing polarity test, you should never try to connect the 3-phase transformer either in star or delta, and the difficulty what will come, that I am telling. I am telling somebody connects like this, although the polarities, actual polarities are like this, but he does not care, star connection, okay, connect, supply. Then what I am telling, look at the individual applied voltage across the primaries. For the A transformer it is A1, A2, for the B transformer it is B2, B1, B2 is connected to Bs, which is 120 degree apart, because your supply is balanced 3-phase supply with phase sequence AS, BS, CS. For C1, of course, CS is connected to C1. Therefore, induced voltage in the secondaries of each of the coils will be parallel to the primary voltages, which for A phase A1, A1, A2, A2, parallel to this. For C phase C1, C2, C1, C2. For B phase B2, B1. So, it must be this way. Getting the point. Now, suppose he says that okay, secondary I have to connect in parallel. He is quite arbitrarily connecting the things. For example, let us assume he is a crazy man. He is telling that okay, star connection. He decides that he will connect like this. Secondary, these voltages are available in this way, and he tells that I will connect the secondary also in star in this way. If he does, then these phasors are no longer staying in isolation. Some of the conditions you have put. What is this condition? A2, B2, C2, you have forced them to be at same potential. Therefore, these 3 phasors, I will draw it here. Sorry, this is not necessary now. What is the Kachi one? Okay. So, this is the thing. So, here from this I now say that okay, this is how you have connected, then these 3 phasors will have their existence like that, you cannot do anything. This follows from single phase transformer fundamentals, but what you have done is you have made A2, B2, C2 to be at, force them to be at same potential. So, A1, A2 and this B2 is there, but B1, B2 will be parallel to this fellow, that will not, you cannot do anything. So, move it parallel, bring it here. Here is the most important point, B2, B1. C1, C2, C2 has been joined with A2, B2, therefore, it will be like this C1, C2, that is what you will get. Length of each of them will be 100 volt, provided you have applied here 200 root 3. Length of this are 200. So, 100 volt, 100 volt, 100 volt, and then he tells that okay, from this you take the output, 3-phase output. Is he going to get a balanced 3-phase voltage? Answer is no. You get some 3 terminals, the voltage of each phase looks like same, but they are not 120 degree apart. So, a balanced 3-phase voltage you are not getting. Therefore, just from the definition of star connections of passive elements, one should not proceed in a 3-phase transformer connection. This must be connected. Of course, just to point it out, if he would have connected in the same way here while connecting, I think you are getting my point. So, I will draw it here. What I am telling? This secondary I am telling, he also connects only the secondaries I am doing, A1 A2, B1 B2 and C1 C2, C1 C2. Now, in the same way star connection he does in the same way like this, as he has done in the primary. Suppose he has done the same way. In that case, of course, this secondary voltages will be balanced 3-phase voltages. Why? Because if you connect like that, what you have done, A2, B1 and C2 you have shorted. So, A2 and B1 you have shorted. So, bring this phasor here. A2, B1 and C2, bring C2 there parallel to this, he will get a balanced 3-phase supply, that is there, but it is left to chances. Whimsically if you do not know. And not only that, the terminals are marked, that is why terminal markings are very essential, and we would also like to see that supply you are giving to A1, B1, C1, take the supply output from A1, B1, C1. Here although you will get balanced 3-phase supply if he connects like that, but there is a mix up, see this is A1, that is B2, this is C1. So, to avoid all confusions, we must adhere to the terminal markings, and this terminal markings business becomes much more crucial if it is delta connections. Okay, star connection, if somebody connects just like that without with any due regard to the polarity, then this kind of situations may happen. You may not get balanced 3-phase output voltage of, although you have connected a balanced 3-phase voltage there, and if you see and you can argue, oh, I have connected the primary in star, secondary in star, still I am not getting balanced 3-phase voltage. It is simply because you have not followed the proper dot polarity. Okay. Anyway, so we have discussed about star-star connection, correct star-star connection here. Now, this star-star connection, as you can see, which I have done here in the first slide, is called star-star Y. Generally, this is how it is written, Y Y, star-star, small y for the low voltage side, capital Y for the high voltage side, and then there is a number written 0 degree besides it, y by 0. It means that the primary and secondary are star connected, and phase displacement of the phase voltage with respect to neutral of the secondary side and phase voltage with respect to neutral of the primary side, they are same, no phase displacement vertical, B1, B2, this is the secondary neutral N. So, with respect to neutral, B phase voltage is in phase with B phase voltage of the primary side, B1 with respect to neutral. So, sometimes it is called Y by 0. Okay. Acha, in this connection, I will use better a new page. So, better do not do star connection not like that. Okay. This is it is not at all suggested to do like that. You always carry out the connections as per. So, let me come back to this one A 1 A 2 and I will be henceforth drawing very quickly and you have understood me hopefully what I mean. These are very important. B 1 B 2 primary, each secondary, B 1 small b 2, these are dots, and this is the third transformer. I have named it C transformer, that is why its terminals are like this. Okay. This is the proper polarity connection. Now, and suppose let me go like this. I have joined A 2 B 2 C 2, I have connected supply A S to A, B S supply B S and supply C S. I have connected like that. Phase sequence is A B C. So, that the primary applied voltage I will connect, it will be A 1 which happens to be A S supply. These 3 points I have joined, they must be at the same potential and that is the neutral, and then supply B S I have connected to B 1 only. So, this is capital B 1 which happens to be same as supply B S and then your, and these are 120 degree apart C 1 and this is also C S. Generally A S, B S, C S we may avoid. And in the secondary, as I told you, I have got, suppose I have not connected anything, but these things are available, these voltages A 1, A 2 parallel to this A 1, A 2, B 1, B 2 parallel to B 1, B 2 in this case, and this C 1, C 2 parallel to this C 1, C 2, these are available. Now, suppose somebody says I will connect the secondary coils in star, but this time I will join it like this. I will short A 1 B 1 C 1. Okay, I will short it. If you do this and I will take output from A 2 B 2 C 2. Then what he is essentially doing? The moment you connect this, these phasors are not in isolation. A 1, B 1, C 1 are at same potential. So, what you do is this, you have to now move these phasors in such a way that A 1, B 1, C 1 are at the same potentials, but nonetheless A 1, A 2 will be parallel to capital A 1, A 2, that is the boundary condition, because single phase transformer each one of them is. Therefore, they must satisfy the principle of transformer. So, the way if you connect this is suppose A 1 A 2. Now, I have joined B 1 with A 1. Therefore, what I will do is this, I will move this phasor parallel and put it here B 1 B 2, getting the point. Similarly, C 1 C 2 I will put parallel and put it here C 2 C 1. Then you know it is also a correct balanced 3 phase output voltage you will get across A 2 B 2 C 2. But this time this is the neutral, this is the secondary neutral, A 2 B 2 C 2 is the primary neutral. Then I will say, and also see the supply phase sequences A B C, everything is fine, and there is no mix up of these terminals. If it is A 2 B 2 C 2. Earlier case there was a mix up, although balanced 3 phase you will be getting here, but it is A 1, it is B 2 C 1. Technically correct, I mean it will work, but the point is I should be very systematic in doing that, so that things are standardized. Okay, there are so this is the thing. Here is also no mix up A 2 B 2 C 2, balanced 3 phase sequence is A B C like that. and if you apply here each one of them 200 volt this length, each one of them is 100 volt. Of course, scale I am not properly drawn, these are much less here. I think you got the idea, just to explain that I am doing. So, anyway, these are 120 degree. So, balanced 3 phase voltage will be available. Now, this connection diagram, how do I specify? Earlier one was y 0, and this one I must then say it is y star connection secondary, star primary, and perhaps I will write 180 degree, because a phase voltage with respect to neutral of the secondary side is 180 degree a phase voltage of the primary is this. These are parallel. Na? So, a phase voltage A 1 with respect to the primary neutral and a phase voltage of the secondary with respect to neutral of the secondary side, they are 180 degree apart. That is why it is called y by 180 degree. Okay. And sometimes we will soon tell you that this is also, people say it is y by 6. Why this 6 I will come slightly later, but I hope you have understood the importance of dot connections. You cannot just have a general way of connecting star. 3 resistance do not bother, connect in any way, star star, delta delta, but in case of transformer connection you should be extremely careful. So, I will now discuss one delta connection. Let us see. So, I take suppose I want to do star delta connection. Of the same 3 phase transformer. So, once again follow the steps, draw the coils A 1, A 2, each secondary, small a 1, a 2, second transformer B coil B 1, B 2, second transformer B coil B 1, B 2, and third transformer C 1, C 2, and its C 1, C 2. Number of turns of each of the secondaries are same, each of the primaries are same. Okay. That is understood, because the ratings of each of the single phase transformer, I have taken 3 numbers of this transformer. What is that? 200 volt, stroke 100 volt, 5 kVA, 50 hertz, single phase transformers. 3 numbers I have taken, each one of them is this. Achha, now, what I say, then I will, I have, as I have told you, I will always maintain this. These dots I have marked with 1 and other things left open. So, this is the dot convention. Achha, now suppose I connect them in star, proper star, A2, B2, C2, and here is my supply terminals AS, BS, CS, phase sequence is ABC. Therefore, the primary voltages I can immediately draw. Is not? That is this one is A1, A2, and A1 is AS, that I am not writing. Similarly, here it is B1, B2, A2, B2, C2 I have shorted, C1, C2. This whole thing is the primary neutral, and the length of each one is 200 volt, because I, let us presume that I have applied 200 root 3 here. Now, on the secondary, as I told you, next step is they first keep them in isolation. You have these 3 phasors available with you, whose length is half of this length, and each one of them is parallel to their respective primary voltages. So, B 1, B 2 parallel to this line, and this line and this line 120 degree apart. So, angle between them is also 120 degree. Similarly, here parallel to C 1, C 2. Length of each one of them are same. This slightly has become more. So, this is the thing. I hope you have understood. So, this is how it is there. Now, what is delta connection? Delta connection means you have to connect for 3 rheostat I was telling na, let me repeat. This way always think now, you are now much more matured. Connect them in series, closed the series, and from the junctions take the output. It has become a delta connection like this, okay, like this. Achha. Now, here you see that suppose I connect without much discussion, suppose somebody knows this and he connects it like this. He joins these 2 points, he joins these 2 points, and he is planning to join these 2 points. And suppose he has connected a switch there to complete the delta, suppose. Now, these 3 phasors are in isolation. The moment you make a connection like this, they are no longer in isolation. So, now you position these phasors based on these connections. For example, here was A 1 A 2, I draw that once again A 1 A 2, but I have connected A 2 with B 1. So, what I will do? I will shift this phasor here, keeping it parallel to this and put this B 1 B 2 here. Are you getting me? Because I have connected. So, A 2 and B 1 must be at same potential. Earlier I was joining A 2 B 2 C 2 or A 1 B 1 C 1, but I have joined only this A 2 and B 1, I am certain they are at same potential. So, move this phasor here. Then you have to connect what you have done, what connection you have made B 2 with C 1. So, move this phasor here such that C 1 is connected here, C 1 is put there and C 2 is here, is that? This is how it will be connected. Got the point? Now, suppose I take a voltmeter and connect across this switch. I measure the voltage across A 1 A 2, these all will be 100 volts. Here voltage across this coil, voltage across this coil 100 volts. What will be the voltmeter reading across this coil? That is V C 2 A 1, here is a switch which is kept open. I have connected them in series, but somehow I am telling you I have not closed it yet. Tell me what is the voltmeter reading? What will be the voltmeter reading? If you can tell me, you are halfway through. Yes, voltmeter reading is V C 2 A 1, is not A 1 and C 2, these 2 points. And what is the voltage between C 2 and A 1? It is 0, it is equal to 0. Therefore, even if it is closed, C2 will whether it is closed or not, C2 and A1 there is no potential difference. So, you can close this, no problem, no circulating current. Although each one of the coil has become a seat of EMF, they are connected in series and you are closing those, but these are 120 degree apart balanced 3 phase voltages. So, resultant will be 0, no circulating current, nothing. So, this is a successful delta connection. We will continue with this in the next class. Thank you.